Hi there, Engineering Science. It's Mr. Young back again with an analog electronics series circuit tutorial. It's for N5 peoples here. Just a wee spiel about it there. Obviously today we're going to look at a bit of series circuit or simple series circuit and what they look like, and be able to calculate them and be able to sort of figure out how to get a total resistance in a series circuit. Alright, so electronic circuits, analog electronic circuits. Basically, there are these different types of components here. You can see this rectangle on the left hand side here for our I'll get a laser pointer. This one here is a resistor, and you can see it's a picture here as well. You can see the little device there. It'll help to control the circuit. You've got your bulb or the lamp. It's not a battery, it's a cell actually, and we've got a wee switch in this one. This isn't exactly the same, but it's just an example of analog electronic components in a breadboard that's used to prototype a circuit. Okay, so you get two different types of electronics: analog electronics and digital. There's a difference. For analog electronics, it's a way of being able to control the signal or the output. So if you think about a dimmer switch in your maybe in a living room or in a bedroom, you can use the dimmer switch to make the lights dimmer or brighter. That's what you're doing, is you're trying to control that kind of the current in the circuit there to try and get a different sort of brightness in the bulb, or different speeds in a motor. It just depends. Okay, the difference between the analog and digital is digital's either on, which is up here, that's on, or it's off. Okay, it's just as simple as that. That's the difference between it. In a digital picture, there's a little IC, or as people might refer to them as hex bugs, but they're an integrated circuit that goes into like a printed circuit board. So the slight differences, these are just components that could go into this. There's no problem in doing that, but usually these would be just separate, being able to sort of make up circuits yourself, whereas this would be a bit more technical, being able to print things onto a board and stick things into a board. Okay, so they do cross over, they do kind of match up together, but mostly that's the difference between analog, a variable signal out, and digital, either on or off. Alright, so we're going to stick to analog just now. These symbols, you get to know them as we go through. Most important ones really: switch, resistor, as we've noticed already, bulb or lamp. Not so much about the buzzer, but lamp. LED, there's a symbol for that, and motor. Okay, other ones you'll pick up, so don't really worry if you don't know what a photodiode is just now, or thermistor. The ones that I've got across them, you don't really need to know them for the course, so don't worry about sort of learning those. You don't have to as you go through the course, you'll be able to pick them up, and it's more the chance that you get to use them in circuits, the more that you'll kind of understand what they are. Alright, so what's a resistor? Resistor basically is a bit of metal, but it's put in a circuit to protect output components like a bulb or an LED. Okay, so it's there to kind of protect and sort of limit the flow of current through the circuit. It does that by turning the electrical current that goes in to the resistor into heat, and that's why you get a wee bit of kind of warmth off the resistor. So it's taking it, it's kind of strangling that current a wee bit, so that the current that goes through an LED or a lamp isn't so much. It doesn't blow it straight away, and you need them for these LEDs and lamps because they're quite kind of fragile. Level of resistance is measured in ohms. Okay, after the person that discovered it or found out about it and investigated it, and it's the omega ohm that we use. You might see sometimes a circuit that will have an R. That just means, like, if it's 50 R, it means 50 ohms, because it's just 50 resistance. I tend to use ohms. It's always best to use ohms because that's what they'll probably be more looking for in an exam. Okay, for how to calculate one out, is we'll get these up here. We just, in a series circuit, even though the resistors here are going round the corner from each other, could even be another one in here or here or here, doesn't matter. There's two resistors here, and all we do is add them together. So the total resistance, RT is total resistance, is equal to R1 plus R2. Okay, if you have more resistors in here, then it could be R3. If we had 5 resistors in here, it would be R1 plus R2 plus R3 plus R4 plus R5, and it just keeps going. If you have 100 resistors, then it's going to be 1 plus 2 plus 3, etc. up to 100. Okay, and so the simple as total resistance is equal to R1 plus R2 in this case. This could be R1 here. This is R2. Doesn't really, you wouldn't know because they're the same value. So 50 plus 50, surprise, surprise, is 100 ohms. Okay, now it's as simple as that for resistance in series, so you don't have to get any more complicated than that. We'll finish it here. I wish everyone, obviously, hopefully they'll stay safe, and thanks for watching, and we'll catch up again with resistors in parallel.